Welcome to the video on pressure equilibrium. I wanted to talk about this one specifically. We're basically dealing with two kinds of equilibria in this unit, Unit 3. We're dealing with Kc, which is concentration equilibrium, and Kp, which is pressure equilibrium. This only occurs when you have products and reactants in the gaseous phase. So if we have A plus B makes C plus D, and all of them are gases, then you could write a Kp expression of products over reactants still. But the major difference is we don't see the brackets here, we see a giant P. That P stands for pressure. So the pressure of chemical C raised to the C coefficient times the pressure of chemical D and the pressure of chemical A and pressure of chemical B. If you, on the test, write Kp and then you put the things in brackets, they will count this absolutely wrong. You'll get 0 credit for that. If you're doing Kp, you are not doing concentrations, you are doing pressures. And they want to make sure you understand what these brackets mean. They mean concentration. P stands for pressure. So make sure you get that right on the test. And the other thing I just want to talk about is that Kc does not necessarily equal Kp. It can under certain circumstances, and I'm going to leave it to you to figure out what those circumstances will be, but let's show you how they actually do relate. Kp is Kc times RT raised to the delta N. Hopefully you already know what those letters are right now, but just to recap, R is gas law constant. Then you're thinking to yourself, well, heck, there's a whole bunch of gas law constants. How am I supposed to know which one? The one you want is the 0.082 liters, atmospheres, moles, Kelvin. Okay, so that's your gas law constant. T is your temperature, obviously. And as always, temperature has to be in Kelvin. Cannot have temperatures in Celsius or I will shoot you. Delta N, delta means change, N means moles. So your change in moles. In this reaction, it will be whatever is C plus D minus A plus B. So products minus reactants. How many moles of the products do we have minus how many moles of the reactants do we have? And then based on this equation, you can figure out when is the only time the Kc actually does equal Kp. Just a funny little thing to help you remember this formula. Some people say this is called the curtain formula. KRTN, curtain. So Kp equals